Good morning to all. Today we are going to discuss two concepts, basic path testing and the second one, control structure testing. So in that first one is basis path testing. Basis path testing is a continuation concept of white box testing concept. So what is meant by basis path testing? Basis path testing is a white box testing technique. It was first proposed by Tom McCabe. So basis path testing, it's not a individual concept, it is a continuation concept of white box testing. For white box testing, have a technique to test any concept. So that technique under here we are saying as basis path testing. So basis path testing is a white box testing technique. This technique may have four different points. Those are first one, flow graph notation, second one, independent program paths, and third one, deriving test cases, and fourth one, graph matrices. Before discussing these points, we must know what is meant by path testing. So path testing is the most important concept in testing environment. For example, take a program. It may contain 10 lines. To write that program, first what we are doing, we are writing or we are designing a flow chart. Flow chart means a pictorial representation of a program. So by using flowchart notations, we are drawing the flowchart or the pictorial representation of that program. So in that flowchart also, we are representing some statements. So a path means, generally we are saying as a path means a way. So here also, to test the program, we are designing the ways, nothing but paths. The paths may contain statements. So a path may contain statements. So in a path, compulsory we must have a starting statement and an ending statement. But in path testing, these statements are represented as nodes, and these nodes are communicating one to another by using edges. So statements are included in the nodes, and nodes may communicate with another node with the help of edges. So this is the concept of path testing. So we are testing the program with the help of paths. So paths may contain some statements of the program. Each statement may contain starting and ending statement compulsory. In between, number of statements may be presented. So this is the total concept of path testing. So basis path testing is a white box testing technique, and it is proposed by Tom McCabe. So now come to the first point, flow graph notation. So to represent this path testing, we can represent in the form of flow graphs manner. So to represent that flow graphs, we need some notations. So that is given here. The flow graph is contain a simple notations for the representation of control flow called flow graph or program graph. That means, for example, if you take a program contain 10 lines of statements, that program for our path testing, we are converting that one into flow graph. That flow graph we can also call as a program graph also. That means how we are writing a program into flow chart. In the same manner here also we are converting our program into flow graphs to test or to implement path testing. So to convert that one, we required some notations. Those notations we are saying as flow graph notations. Now here, these are nothing but some structured constructs in flow graph forms. For example, in your flow graph, if you want to represent your statements are flowing in sequential manner. We know what is meant by sequential, linear, one by one. So one statement executed first and afterwards that one second statement will execute and then third one, fourth one in the linear manner, a sequential manner. The flow is going on. So to represent that sequential in your flow graph notation, we are representing in this manner. Already I said in the flow graph, the statements are represented in the form of nodes. The circles will be called as nodes, and the relationship exists between the node to one node to another node with the help of edges. The arrows here we are calling as edges. So a sequence will be represented in the form of in this format in the flow graph. If you come to the second one, if statements are there, the such type of if statements in the flow graph we are representing in this form. For example, if you take one node, it contains a if condition. If a greater than 0, if it is true, it will move in this form, in this way to another statement. Or otherwise, if it is false, it will move in this way to another statement. After executed either this or that, it may comes again into the actual flow. So it come to here and then it will be flow in that sequential format. So if you want to represent the if condition in the flow graph, you can represent in this format. Then if you come to the third one, if you want to represent while condition or while statement, you can represent in this format. In while we have loops. So we have loop format. So to represent a while, you can represent in this format in flow graphs. Until you can represent in this format, and cases, nothing but switch cases in your Java program or C++, case, switch cases or case, we can represent in this form in flow graphs. So this is the flow graph notations. So if sequential, we can represent in this format, if like this, while like this, cases like this. So now we are going to see the flow graph of a program. For example, if you take a program, it may contain 11 statements. So for those 11 statements, first what we are doing, we are designing the flow graphs. So this is nothing but a flow graph format. Just assume a program, it may contain 11 statements. Statement 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 statements are there. With the help of that 11 statements, we are designing this flow chart. So based on this flow chart, we are converting that one into flow graphs. So already I said in the flow graphs, there is only two concepts. One is nodes, nothing but represented in the form of circles, and the relationship exists between the two nodes are represented by edges. So these 2 points only in the flow graphs. And another point is in the flow graph, we can combine 2 or more statements in a single node, but it is not exist in the flow chart. For each and every statement, we want to represent individually in flow chart, but in flow graph, we can combine 2 or more statements. That's why we are combined here. Statement 2 and statement 3 are placed in a single node, and statement 4, statement 5 are placed in a single node. So why we are combined means, how we can combine means, if these 2 nodes are similar type of statements, then we can combine and placed in a single node. It is possible in flow graphs. So now come to the flow graph. So why we design the flow graph for a program is, we can easily test the flow graph by using path testing. So with the help of flow graphs only, we can define the paths. How we can define the paths means, we have a concept called cyclomatic complexity. With the help of those cyclomatic complexity, it provides a value. Based on that value, we can find how many paths are there. So by testing all those paths, we can test the program completely. We will discuss the cyclomatic complexity later. For that, a simple and small concept will be used here. That's nothing but regions. So in this flow graph, we have 4 regions. So region 1, region 2, region 3, region 4. So how we can find a region is it is covered by nodes and edges. So if you take region 1, it is covered by nodes and regions, and the R2 region, it is covered by nodes and R3 nodes and edges, and R4 is the total outside region. So this flow graph may contain 4 regions. Please keep this point in your mind, we will use later. So this is the concept of flow graph, and this is the overall concept of flow graph notation. Then what is the second point? The second point is independent program paths. So what is meant by an independent program path? An independent program path is any path through the program that introduces at least one new set of processing statement or a new condition. That means, for example, based on our DAG flow graph, we selected a path. So a path must contain starting and ending, and it must and should contain at least one processing condition or a new condition. So a condition means nothing but it must provide a boolean value. For example, if you take if a greater than b, it's a condition. So here if a is greater than, if it is true, it goes to one side, true side. If the a greater than b is false, it goes to false side. So a greater than b is a condition. That means if an independent program path means it must and should contain at least one processing statement or a new condition must be there. So for this concept, take a simple example. A set of independent paths from the flow graph illustrated in figure B is path 1, 1 to 11, path 2, 1, 2, 3, 4, 5, 10, 1, 11. So how it is? Just come to the diagram again. So first path 1 is 1 to 11. So 1 to 11. So you may think there is no any statements here. Just come to the flow chart. Here 1 to 11. Here 1 is a condition statements. So what an independent program path says, at least one processing condition or a new condition must be exist. So here 1 is a condition statement. So we can say this is one of the path, and this path may have starting node is 1 and ending node is 11. Here also starting node is 1 and ending node is 11. So node 1 is also a condition. So that's why this independent path 1 to 11 may contain a condition statement. In the second path 2, 1, 2, 3, 4, 5, 10, again 1 and 1 to 11. So this is your second path. So how we can take this one as an independent program path? That means it must and should contain at least one condition. So now to represent or to know that one clearly, just come to the flow graph. So what they say, 1 is also a condition. Then 1 to 2, 2 to 3 is also a condition. So that means at least one condition, but here 2 conditions are there. So this path is also we can treat it as an independent program path. So this is the concept of independent program path. An independent program path may contain is a path through the program that introduce at least one processing statement or a condition. So this is the concept of independent program path. It is a path must and should contain a processing statement. So this is the concept of independent program path. Then goes to third concept. In this independent program path, the second point is cyclomatic complexity. So cyclomatic complexity is a software metric that provides a quantitative measure of the logical complexity of a program. That means So cyclomatic complexity is a software metric. It provides a quantitative measure. That means you have a program, and based on that program we designed a flow graph also. So with the help of flow graph we are going to do path testing. So how many paths are enough for us to test the total path, sorry, the total program? But there is a condition in path testing. So when you use path testing, you must test all the conditions in the program at least once. At least once you must test all the conditions in the program. That is the most important point in path testing. So you want to know how many paths are there in the flow graph. It must cover all the statements. To know the number of paths in the flow graph, cyclomatic complexity helps you. So for that computation, so complexity is computed in one of three ways. That means we can compute that cyclomatic complexity value by using this any one in these three ways. Three ways are there. By using any one of the way, we can find out the cyclomatic complexity. In that, the first way is the number of regions of the flow graph corresponds to the cyclomatic complexity. That means in the flow graph, how many regions are there? That value, that region value. For example, let's go to our diagram. So in this diagram, in this flow graph, we have 4 regions. So cyclomatic complexity of this flow graph is 4. So number of regions of the flow graph corresponds to the cyclomatic complexity. Based on the flow graph diagram, we have 4 regions. So cyclomatic complexity of that flow graph is 4. So second way to finding the cyclomatic complexity is cyclomatic complexity of Vg for a flow graph G is defined as Vg is equal to E minus N plus 2. So this is the second way. So here E means number of edges and N means number of nodes. So for example, come to this diagram. So in this flow graph, how many edges are there? So basically 11 edges are there. Come to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 edges are there. So 11 minus N. N means number of nodes. So how many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 nodes are there. So based on our formula, V of G is equal to E minus N plus 2. So 11 edges minus 9 nodes. 11 minus 9, 2. 2 plus 2, 4. So how many regions are there? 4. So 4 is the cyclomatic complexity based on the first point, and based on second one, so 11 minus 9, 2, 2 plus 2, 4. So 4 is the cyclomatic complexity of our flow graph. Then if you come to the third way, cyclomatic complexity of V of G for a flow graph G is also defined as V of G is equal to P plus 1. So here P is nothing but is number of predicate nodes contained in the flow graph. So according to our flow graph, there are 3 predicate nodes are there. So 3 plus 1, 4. So 4 is the cyclomatic complexity. So in the by using any one of the any one in these 3 ways, we can find out the cyclomatic complexity. So this is the concept of cyclomatic complexity. Then the third point in basis path testing is deriving test cases. So how we can derive test cases for testing the programs. So for this, the basis path testing method can be applied to a procedural design or to source code. So to derive the test cases, we are applying the basis path testing method on any procedural design or our source code. So we are applying these path testing methods on our source code. So the following steps can be applied to derive the basis set or test cases. So what are those steps means? First one, Using the design or code as a foundation, draw a corresponding flow graph. So first point is we want to design the flow graph. So to draw the flow graph, we must use the source code. So what is the program we have? Based on that program, we want to design the flow graph. So first step is we want to design the flow graph based on the code. Then second step is determine the cyclomatic complexity of the resultant flow graph. So once the flow graph is designed, we can find out the cyclomatic complexity. So by using the cyclomatic complexity value, we can define how many paths are required to test the total program. So in the second step, we want to determine the cyclomatic complexity based on the flow graph. Then the third step is determine the basis set or test cases of linearly independent paths. So design or determine the test cases or basis sets for linearly independent paths. So how many paths are there? We can know by using cyclomatic complexity. For those independent paths, we want to determine the basis set or test cases. After prepare the test cases that will force execution of each path in the basis set. So those test cases forces the execution of each path. So each path in the basis set. So when you execute each path, we can test all the statements in the program and we can test throughout the program and finding out the errors. So in this manner, we can deriving test cases by using these 4 steps. Then the fourth concept is, fourth point in basis path testing is graph matrices. So the graph matrix is nothing but when you want to design or develop any software tools, flow graph design or flow graph notations are very difficult to design any software tools. This representation, flow graph representation is some problematic or difficult concept to design any software tools. For that, what we are doing here is we are converting the flow graph into matrices. So that is the concept called graph matrices. How we are converting, how we are developing these graph matrices means first we want to know the size of the matrix. How we can determine the size is how many nodes in the flow graph that gives the size of the matrix. For example, in this flow graph we have 5 nodes, 1, 2, 3, 4, 5 nodes are there. So the graph matrix size is 5 into 5 matrix. So 5 rows and 5 columns. So 5 into 5 matrix. The number of nodes in the flow graph count will give the size of the matrix. And how we will fill the data in that matrix means in the flow graph the weights, edges weights are nothing but the data, filling data in that matrix. How we can fill this one means just come to the point. So A is the weight which is flow from node 1 to node 3. So from node 1 to node 3 flow, it carries the data is A. So this A we want to fill in the matrix. How we will fill means the starting node will act as row and ending node will act as column. For example, if you take the value A means its flow from 1 to 3. That means first row, third column. So first row, third column. That intermediate column cell will be filled by the value A. So the A is filled in the starting node 1 will be treated as row, first row, and ending node 3 will be treated as third column. So first row, third column. That intermediate cell will be filled by the value A. In the same manner, B is filled in the place of third row and fourth column. Third row and fourth column B. And C will be filled here as fourth row, second column. Fourth row, second column. And D is filled here as third row, second column. Third row, second column. So in this manner, we can fill the data in matrix also. So this is the concept of graph matrices. So this is the overall concept of basis or testing. In basis part testing, we have four concepts. We covered four concepts. Those are: first one, flow graph testing; second one, independent path program path; third one, deriving test cases; and fourth one, graph matrices. So these are the 4 points in basis part testing. Then the second concept is control structure testing. Control structure testing containing 3 points. One is condition testing, and second one data flow testing, and third one loop testing. In this, first one is condition testing. Condition testing means it is a test case design method that exercise the logical conditions contained in a module. So, for example, if you take a program or a program module, it contains some logical conditions. Conditions means here we can take as if conditions, while conditions, etc. If a greater than b, while a less than n greater than 2, or like that, such type of conditions will be there. To testing such type of logical conditions or conditions, it comes under condition testing. Then the second one is data flow testing. So data flow testing means selects test paths of a program according to the location of definitions and uses of variables in the program. So this means, for example, if you take a condition, that means if a greater than 0, if you take this condition may have two answers. If a condition a greater than 0 is true, then it goes to one side to execute some statements. If you take a greater than 0 is false, it goes to another side to execute some statements. For example, if you take a greater than 0 is true, it goes to right side and executing some statements. In that execution, the data is flowing from right side way. That means the variables, with the help of the variables, the data is flowing. That in the data flow is in a right manner. To test that one, we are using the test concept called data flow testing. So how the data is flowing, if the data is flowing in a right way or not. So to check the data flow is nothing but data flow testing. Then the third concept is loop testing. So loop testing is a white box testing technique that exclusively on the validity of loop construction. That means what are the loops we have? We have for loop, while loop, do while loop, etc., etc. So those loops are all executing in a right way or not, they are validly constructed or not. To check that one, we have a testing concept called loop testing. So under this concept, loop testing may have 4 different types of loops are there. Those are nothing but: first one, simple loops; second one, nested loops; and third one, concatenated loops; and fourth one, unstructured loops. So in these 4, the first one is simple loops. Simple loops means simple loops, just like while loop or if condition, if while loop, like that. So a condition will be there. If it is true, execute some statements, and if the condition is false, go to next statements. These types of simple loops comes under simple loops testing. Then come to the second one, nested loops. Nested loop means, we already know, nested means for one we have another one inside of that, in that we have another one inside of that. Such type of concept we are calling as nested. In the loops also, if one loop may containing another loop inside of that, if this loop may contain another loop inside of that, then such type of loops are called as nested loops. Nested loops, one loop may contain another loop inside of that. Such type of loops are considered nested loops. Then third one is concatenated loops. Concatenated loops means nothing but it is also just like a simple loop format only. That means, so this is a loop 1. It is a simple loop. So in loop 1, so what is the result is executed here. That result may goes to the value for loop 2. And here also we have another loop. That means combination of two simple loops. It comes under concatenated loops. Then fourth one is unstructured loops. That means a very clumsy and it contains nested loops, simple loops, concatenated loops. In that manner, clumsy manner, all different types of loops are existed, one below of one inside of another one, and creating some clumsy environment, difficult environment. Such type of structure will be called as unstructured loops. So these are the four different types of loops are existed in loop testing concept. So these are the three concepts. So these are the three concepts in control structure testing. So today we discuss two concepts, nothing but basic path testing and second one control structure testing. Based on these two concepts, some assignment questions are given for you. So these are those assignment questions.